Have you ever gazed up at the stars and wondered if we are alone in the universe? It's a thought that has crossed many minds, sparking curiosity and a desire for understanding. When we consider the sheer magnitude of the cosmos, the mind boggles. Picture this: billions upon billions of galaxies, each teeming with countless stars. And around these stars, orbiting in the Goldilocks zone, are planets, potentially capable of nurturing life as we know it. Now, consider this. The universe has been around for nearly 14 billion years, providing ample time for life to emerge and evolve. With such vastness and such time, the probability of the existence of extraterrestrial life seems not just plausible, but likely. Yet, despite our technologically advanced telescopes and our ever-increasing understanding of the universe, we've yet to find any definitive sign of life beyond Earth. This leads us to an intriguing question. If there is such a high probability of life, why haven't we found any evidence yet? This question is the essence of what we call the Fermi paradox. Now let's delve into the heart of this paradox. Named after the Italian physicist Enrico Fermi, the Fermi paradox is essentially a contradiction, a riddle wrapped in a mystery inside an enigma. It's a cosmic conundrum that has puzzled scientists, philosophers, and curious minds alike. Imagine this. You're sitting at a table with a deck of cards, and you're told that there's a high chance that one of the cards is an ace. But as you flip over card after card, you find no ace. This is the essence of the Fermi paradox. It's the contradiction between the high estimates of the probability of extraterrestrial life and the lack of evidence or contact with such civilizations. Let's break this down a bit. Our universe is vast, unimaginably so. There are billions upon billions of stars in our galaxy alone, each potentially hosting planets, and that's just in the Milky Way. Consider the multitudes of galaxies that make up the universe, and the number of potential life-supporting planets becomes almost unfathomable. Given these astronomical numbers, many scientists argue that the odds of Earth being the only life-supporting planet are incredibly slim. Life, as we understand it, requires certain conditions to flourish, true. But, with such a vast number of planets, it seems statistically probable that these conditions must have been met elsewhere. Yet, despite decades of searching the skies, we have found no signs of extraterrestrial life. No signals, no spacecraft, no clear evidence whatsoever. We've sent out probes, broadcast messages, and listened with our most powerful telescopes, but the universe remains eerily silent. And therein lies the paradox. If the universe is brimming with life, if there are civilizations out there that have existed for millions or even billions of years, why haven't we found any evidence of them? Why haven't they contacted us? Why is it that in this vast cosmic ocean, Earth seems like the only island teeming with life? So if the cosmos teems with life, why do we feel so alone? The Fermi paradox brings us face to face with some fascinating possibilities. Diving right into the heart of the matter, the first main point of the Fermi paradox posits the possibility that we might be alone in the universe. This is often referred to as the rare Earth hypothesis. It suggests that the conditions necessary for life as we understand it are so complex and specific that they may only have occurred once, here on Earth. The precise combination of factors such as the right distance from the sun, the presence of water, and a stable climate, among others, might be so rare that we are indeed a cosmic anomaly. The second key point of the Fermi paradox considers the possibility that extraterrestrial life is out there, but it's avoiding us. This is known as the zoo hypothesis. It suggests that advanced civilizations might be observing us like zoo animals, choosing not to interfere or make contact. They could be waiting for us to reach a certain level of technological or social development before revealing themselves. Alternatively, they might be avoiding contact to protect us or themselves from potential harm. Another intriguing point is the idea that we're not listening correctly or looking in the right way. This is the SETI hypothesis. SETI, or the Search for Extraterrestrial Intelligence, has been scanning the skies for decades, listening for signals from other civilizations. However, we're limited by our own understanding and technology. We assume that other civilizations would communicate using similar methods and technologies as us. But that might not be the case. They could be using means of communication that we haven't even conceived of yet. The fourth point to consider is the Great Filter hypothesis. This suggests that at some point in the development of a civilization, there's a hurdle or filter that's difficult to overcome. This could be anything from a natural disaster to self-destruction through war or environmental damage. If this is true, it's possible that many civilizations have existed, but didn't survive long enough to make contact. Lastly, the simulation hypothesis suggests that our reality might just be a simulation created by a more advanced civilization. If that's the case, then it's possible that we're alone in this simulation, or that any extraterrestrial life we encounter is also part of the same simulation. Each of these theories has its own implications, and each raises more questions than it answers. The Fermi paradox isn't just about whether we're alone in the universe, it's a lens through which we can explore the nature of existence, the future of humanity, and our place in the cosmos. The paradox continues to fuel our curiosity and drive us to seek answers to some of the universe's most profound questions. There are several theories that try to resolve the Fermi paradox. One of the most intriguing among these is the zoo hypothesis. This theory suggests that extraterrestrial civilizations are indeed out there, but they are consciously avoiding contact with us. They're observing us, much like we observe animals in a zoo, without interfering in our natural evolution. It's a fascinating possibility, suggesting that we are part of a much larger cosmic story, but with no hard evidence it remains just that, a possibility. Another popular theory is the rare Earth hypothesis. This states that the conditions necessary for intelligent life are so specific and complex that they're incredibly rare in the universe. It's not just about having a planet in the right location, with the right atmosphere, it's also about having the right planetary formation, the right chemical elements, the right kind of star, and a stable environment over billions of years. If this theory is correct, then we truly are a cosmic anomaly. Then there's the self-destruction theory. This is a somewhat gloomy proposal suggesting that any civilization advanced enough to reach out into the stars eventually self-destructs before it can make significant contact with other civilizations. Whether through nuclear warfare, environmental collapse, or perhaps even a technological singularity, civilizations might be doomed to destroy themselves, leaving the universe quiet and devoid of advanced life. And let's not forget the idea that we might simply not be listening in the right way. Perhaps extraterrestrial civilizations are communicating in ways we can't yet comprehend or detect. This would mean that the universe might be teeming with chatter, but we're just not tuned into the right frequency. While these theories are compelling, none can definitively answer the question posed by the Fermi paradox. Each provides a possible explanation, but until we have concrete evidence, the paradox remains, and the question still echoes through the cosmos. Where is everybody? The Fermi paradox forces us to confront the unknown. It's a challenge that dares us to rethink our place in the cosmos, and reconsider our understanding of life itself. It's a riddle that toys with our curiosity, a question that's as vast and complex as the universe itself. The Fermi paradox is a cosmic conundrum, one that pushes us to question our assumptions about the universe's nature and our place within it. It pokes holes in our seemingly logical conclusions about the existence of extraterrestrial life. It's a reminder that our understanding of reality is based on our limited perspective, a perspective that's confined to a tiny planet in the corner of an immense universe. The implications of the Fermi paradox are profound and far-reaching. It forces us to question the uniqueness of life on Earth. Are we a cosmic anomaly, a rare gem in a universe of barren worlds? Or are we part of a cosmic community, with neighbors across the stars that we've yet to meet? These questions challenge our understanding of life and our place in the universe. This paradox also influences our perspective on human existence. It reminds us of our insignificance in the grand scheme of things, but simultaneously highlights our importance. We are the only known life forms capable of pondering these profound questions, capable of reaching out to the stars, capable of seeking answers. In the face of the Fermi paradox, we stand at a crossroads, caught between the desire to explore and the fear of the unknown. It encourages us to push the boundaries of our knowledge, to venture into the unknown, and to seek answers to the questions that have haunted humanity since we first gazed up at the night sky. In the end, the Fermi paradox does not offer answers, but instead it offers a mirror, reflecting our deepest hopes and fears about our place in the cosmos. Until we find concrete evidence, the question remains,